notice, and this is the typical copyright. Right now, we are at section 8, Geometry and Trigonometry. This is the 6th of 24 videos from this section. So we are here. Construct quadrilaterals. First of all, we will deal with parallelogram, square, rhombus, and rectangle. And then we will talk about kite, and then trapezium or trapezoid, and then a hexagon. So this, as I said, is the 6th video in this section. Let's consider briefly what these shapes look like, all of them together. If we consider all polygons in this box here, we can set triangles here in that ellipse. We can set quadrilaterals in this ellipse, and the other regular polygons with 5 or more sides in that ellipse. And then we have irregular polygons with more than 5 sides. As it relates to triangles, there is the isosceles triangles, and within isosceles triangles, there is the equilateral triangle. Outside of those two, there is also the scaled triangle. So those are 3-sided flat figures. Then we come to quadrilateral, 4-sided. We have parallelogram, kite, trapezium. Now, there are different types of parallelograms, such as rectangles. The square is a special type of rectangle. And of course, you have the rhombus here. So these all here are parallelograms, 4-sided figure. But then you have other 4-sided figure like trapezium and kite. So square, rhombus, rectangle, and parallelogram. What do we know about them? They are all plane figures enclosed by 4 straight line sides. The opposite sides are equal and parallel to each other. Opposite angles are equal to each other. The diagonals bisect each other, and the inside angles on the same side are supplementary. So if you look at these diagonals here, that diagonal there bisects this one into 2 equal parts, and the converse happens. And also, the inside angles are supplementary. So this angle here plus that one over there will add up to 180 degrees. Or this one here and that one there will add up to give 180 degrees. So this is what we know about parallelograms, which are a type of quadrilaterals. Construct the parallelogram ABCD with side AB equal 4.0 centimeters, side BC equals 6.8 centimeters, and angle ABC equal 105 degrees. We are going to construct this, so we are not using a protractor. As usual, always make a labeled sketch first. So we take the longer side and make that the base. BC 6.8 centimeters, that is this. We need an angle at B, which is 105 degrees, which is that. And that extends to A, which is 4.0 centimeters. And of course, D is out here. So that's a sketch. Now we have to construct that accurately without the use of a protractor. So first of all, we will construct BC accurately and label it BC 6.8 centimeters. Then at B, we will construct 105 degrees. You know how to do that by now. I don't have to explain that to you. You extend this line through 105, at least 4.0 centimeters, because we will now mark it off. So you open your compass to 4.0 centimeters, and from B, you make an arc along that line, which is this arc. You write in A there, you bold AB, write in 4.0 centimeters there. Remember we said the angles on one side are supplementary? Now this is a harder way of doing this. I will show you an easier way in a little while. Well, if this angle over here is 105, then this angle over here will be 75. That is to say, this angle over here will be 75. So we will construct 75 at this point. Now remember, this is a harder way of doing this work. So after we construct the 75, that would have been 60, 90, 75. We measure 4.0 centimeters. Remember, opposite sides are equal, and mark it off here. So that was the 75 degrees that we constructed. So what we now have is this. You bold from D to C down here, and then you draw a nice bold line from A to D. And that would finish the parallelogram. Like this. This is the completed parallelogram. Make sure you have all the dimensions written in. Now there is an easier method to get this point D, rather than constructing the 75 degrees, drawing that line through it. There is an easier way to get point D. So you are at this point. So what do? You open your compass to the measurement AB, place the metal point at C, and make an arc up there. So from C to that arc will be the same distance as from B to A. So opposite sides are equal. And then you open your compass from B to C, place the metal point at A, and make an arc up here to cut that first arc that we did. So this is what you get. Now remember this point here, that point there is the same distance from C as AB. And it is also the same distance from A as BC. So all we now need to do is draw a bold line there and there. And this is the completed required parallelogram. There is a third method of finding that fourth point up there, D, which I will show you when I'm doing it practically. Construct parallelogram ABCD such that side AB is 4 centimeters, BC 6.8 centimeters, and angle ABC equal 105 degrees. You are to construct it. So first of all, we will make a sketch. Take this longer side and make it the base, which will be BC, which is 6.8 centimeters. This angle at B here will be 105 degrees. That will be 90. 105 will be somewhere here. So remember, this is a sketch. So this is 105 degrees. This side here, up here is A, and this is 4.0 centimeters. Now once you have that, you have to locate D somewhere up here. There are various ways to get that D, as we will find out just now. But if we were to complete the parallelogram, it will look something like this. That will be D. So it's fairly easy to get A, B, C, 6.8 centimeters and 4.0 centimeters. Up here, there are various ways of getting that point. 6.8 centimeters. So let's draw a construction line here, which is a very thin line. We will make sure it is more than 6.8 centimeters. Let's begin somewhere here. Since that angle will lean towards this side, we want 6.8 centimeters. Do we have that? Yes, we have more than that. So we will call this point here B. We will take our compass, open it to 6.8 centimeters. If you are using an opaque ruler like this, then you can use the top of this ruler. 6.8, 6.8. If you are using an opaque ruler like this, if you are using a transparent ruler like that, remember to measure where the calibration is, where the writing is. 6.8. Mark off that. Then come on this side. Bold this line between here. And you write in 6.8 centimeters. Now we have to construct an angle here of 105 degrees. So open this compass to a reasonable amount. That will take us to 60. That will take us to another 60, which would give us 120. That will give us 90. Let's check that. 90. If we bisect that 30, we will get 15. So 90 plus 15 would give us 105. From here, so we draw a line from here to there. We know it is 4.0 centimeters. So we'll draw it much longer than 4.0. We measure 4 centimeters. And we bold from here to here, writing A, 4 centimeters. A, this is 4.0 centimeters. Remember, this angle here is 105 degrees. As you can see, 0, that would have been 60, 120, 90, 105 degrees. This is 105 degrees. Now we need a point somewhere out here, D, such that from D to C will be this distance here, opposite here, and from A to D will be this distance here, which will be 6.8 centimeters. Now there are various ways of obtaining that. The easiest way is to open our compass from here to there, which is 6.8. We can measure it to make sure it is 6.8. Come up here where that A is and make a nice big arc like that. That means that from A to any point on that arc is the same as from B to over here, which is C, BC. Next, we will measure from here to there, which is 4 centimeters. 4 centimeters, we can double check that on our ruler. 4 centimeters. And now, from C, make an arc up here. So this point here meets 2 conditions. From here to A is the same distance from B to C, and from here to C is the same distance as A to B. So all you now need to do is draw a bold line there and there, label that D, and you are finished. And this is D. So you have just constructed the parallelogram ABCD such that AB is equal to 4.0 centimeters, AB is 4.0 centimeters, BC is 6.8 centimeters, and angle ABC is 105 degrees, which is this angle here, 105 degrees. So that is the required parallelogram. Now there is another way to do this that you already saw. If this is 105, then this angle over here will be 75. How do we get that? Remember we said that angles on the same side of a parallelogram are supplementary. So this and this will add up to give you 180. Or this angle over here is 75. These are 2 parallel lines. This is a transversal. So these, that and that will be corresponding angle. So we could have constructed this ABC and then at this point construct 75 degrees, extend it 4.0 0 centimeters to get that point and draw a line from here to here. That's another way. Now, a third way is once we have this ABC here, irrespective of that angle, we don't have this point yet. What we can do is place this here. We know that we need a parallel line up here from A going that way. So set your ruler like that. Press firmly on the ruler. Shift this set square going like that. And once you reach A, you draw a thin line like that. You also need a parallel line, that parallel line, parallel to this from C. You set your set square like that. Remember, we want a parallel line from C parallel to AB. Slide that until you reach C, then draw a light line here, a construction line. And where those two construction lines meet, as you can see there in red, that will be the point. So we have just looked at 3 ways to get this point here, D. Use whichever one is most convenient to you. As long as you get A, B, C, 6.8 centimeters, 4.0 centimeters, 105 degrees. Getting this point D here, you have 3 ways. Take this measurement BC and come at A and make an arc, and then take this measurement AB, come at C and make another arc. The 2 arcs will intersect there. That's the easiest way. A little more difficult way is, you know that this is 105, this will be 75. You construct this 75 here. You can construct 75, extend it like this, 4.0 centimeter, write in 4.0 centimeter, take your compass and mark off 4.0 centimeters there, brighten that line, bold that line, and then bold from here to there. The second way. And the third way, which I think may be the hardest for you, is to draw a parallel line to this from A, like that, a construction line, and then from using AB, draw a parallel line on this side from C. And where those 2 parallel lines meet, you use that. So 3 ways to find D. If you find this video useful and interesting, please like and share. Like and share. You may also consider subscribing to this channel. Now we are going to construct a rectangle, PQRS. This is easier than the typical parallelogram. PQ 5.0 centimeters and QR 7.0 centimeters. Notice you're not given any angle because in a rectangle, all the angles are 90 degrees. So you make a sketch, PQRS, use the longer side as the base here, QR 7.0 centimeter, up here is P 5.0 centimeters. Opposite sides are equal and parallel, and all the angles are 90 degrees. So you sketch QR, you could call that the base, 7 centimeters. You do that first. And then using this point and that point, you open your compass to that amount and you make 2 arcs there. When you draw a line down there, that line will form 90 degrees here. And you do the same thing over here. So you draw in a construction line for 2 right angles. And then you take your compass and you measure 5.0 centimeters. And you mark off 5.0 centimeters on both of those perpendicular. So you get what you see here. Bold all the lines you see there, and now drawing a bold line from P to S, and bold from P to S. And this is the required rectangle. That is one way to do it. Of course, you could have just constructed this 90 degree here a different way, and then take the measurement from P to Q, come over to R, and make an arc like that. And you know that from that arc to R will be the same distance as from P to Q. Once you have that, you measure from Q to R, come up to P here, and make an arc to cut that one there. So you get this. Now remember, that point from R is the same distance as P is from Q. And also this point from P is the same distance as Q is from R. And then you draw a bold line from P to S, and you're finished. That is the required rectangle. The square and the rhombus are constructed in a similar manner as the rectangle or the regular typical parallelogram. Square and rhombus.